Hi there everybody, welcome to another Maths School video. Today we're going to look at box plots. Alright, so it comes in three stages this one, so we're going to start off by looking to draw them. If you don't know what a box plot is, it's about a representation of data in a box, effectively. So when you're drawing a box plot, you've got to space out the numbers evenly, and you must try and calculate the quartiles from a set of data. So we're going to look at that in a bit more detail in a second, just so that you can clear on what those kind of things mean. So you might be given some information, and from there we need to basically put a box plot together. All right. So the height of 100 tomato plants were recorded. All right. Bad English there. The tallest plant is 67 centimeters, and the smallest plant is 36. All right. So that's going to give us our range between 67 centimeters being the tallest and 36 being the smallest. All right. The median. Now that's the value which is right in the middle of the 100. So our 50th tomato, so to speak, would be 54 centimeters, and then the lower quartile is 45 centimeters and the upper quartile is 62 centimeters. Well, those two numbers, if you're not quite sure what those represent, well, if the median is the one in the middle, then the lower quartile will be the one in the middle of the bottom half. All right, so it's split into quarters effectively, and then the upper quartile would be the middle of the top half. All right, so it's kind of those numbers in between. But when we're looking at box plot, it's those numbers that you're given there that basically form the box plot. All right, so let's kind of put them together. So firstly, we even space out the numbers on a number line. All right, so we are going to go from the smallest, which is 36 over here, and it's going to go to the highest, which is going to be 67. All right, so they're the key numbers that needs to go on the top and the bottom. So here you can see we kind of put a scale together. Now you need to plan this out effectively, trying to think about how this would be. But if I'm thinking about an exam and how that might be put together, now you would expect them to give you a decent enough range for you to kind of put those numbers together relatively easily. All right, a little bit like what mine is. So let's kind of get these numbers on here. So the first thing we're looking at is the tallest, which is there. So where's that going to go? Well, 66, 68, 70, so we're looking along this bit. So 67 is going to go roughly around about there, isn't it, where my cursor is currently. All right, so we're going to put a line just there. All right, so that's going to be one side of my box plot. We're now going to look at the smallest, which is this bit over here. So back to the graph, we're going to go down to the bottom, and I think 36 is going to go there. So I would expect another line now just to kind of appear there. There you go. All right, so they're the two, we call those the whiskers, I think they call it. So box and whisker plots, sometimes they're called. All right, so these are our whiskers. They're the edges of our data. We're now going to focus on the other three numbers. Now, the other three numbers are going to form what we call our box. All right, so I'm going to focus on the median. So that's 54. So that's going to be there. So we're going to put another line there. We're going to then look at the lower quartile, 45. So finding that along the graph, I think that's going to be about there. So I'll put a line there. And then the upper quartile, which is this number, which we're looking at now, that's going to go around about there, isn't it? All right, so we have that. So at the minute, it doesn't look like anything other than a bunch of lines. But it needs to, because we've been asked to form a box plot, we need a box and what we call the whiskers that kind of go with it. So this is what we're going to do now. All right, so these three lines here, which we've just drawn, that's going to form the box. All right, these bits on the end here are going to form the whiskers. All right, so you'll see it kind of come together now. So there's the box, that's the box. And then because our data goes up to 67 and down to 36, then we need to put what we call whiskers on. All right, so sometimes called a box and whisker plot, and it'll look something like that, where this box here, which I'm just kind of highlighting there between these two numbers, that represents half our data. That represents our middle number, and the top and the bottom represent the range of all our data. Is that all right? So that's what it's representing. All right, so that's it done. Okay, so reading box plots. Well, this turns it on its head in terms of what we just looked at, doesn't it? So if we've given a box plot, it's about understanding what those mean. So, as we mentioned before, like a box plot is used to show data by separating it into quartiles, which you've currently seen. Okay, the box in the middle section of data and whiskers are used for the outer quartiles, which I've just talked about, and it looks something like that, which again we've just kind of seen. So that number that goes in the middle is the median, so that's where the middle value appears. That's the lowest value on the left-hand side, which you saw before. and of course the highest value on the right hand side. And then this value and this value are our two quartiles, so lower quartile and upper quartile. All right, so that terminology is worth knowing, because again, it might be they ask you to kind of plot it based on the information you're given. It might be that you're given data and has to kind of calculate that, and you might come across that when we're looking at cumulative frequency in a similar kind of guys. So you might not look at one of those videos about cumulative frequency, because cumulative frequency and box plots are often kind of put together in exams. So please do look at that one as well. So here's an example. All right, so we've got a piece of information, and of course, if we're going to read it, we're going to try and interpret it, and we're going to try and look at what it's actually telling us. Okay, so where's the median? Well, that's the number in the middle of the box. So that's going to be 12. So that's going to be the middle value. Okay, the lowest value, well, that's right at the bottom of the left whisker. All right, so right down the edge. So that's going to be 2. And then we've got I'm guessing it's going to ask me for the highest value. Yeah, it does, which is going to be over here. So that's going to be 16. And then it's going to ask me the lower quartile. You get the picture here, don't you? And that's going to give you this number. So in between 6 and 8, it's going to be 7. And then what do you reckon next? The upper quartile, of course it is, which is going to give you that number there. All right, which is going to be 14. Now, there's one other question which often kind of comes into play, and this will be called basically the interquartile range. You can see it labelled there as IQR. Now, the interquartile range is a little bit like the range. All right, I'll mention the range now. Hopefully, you can see. So, if I was asking for the range of this data, it goes from 16 down to 2, doesn't it? So, it would have a range of 14. All right, for the whole data. But the interquartile range, because we're talking the quartiles, the upper and lower, is the range between these two little beauties here. All right, so looking at this one, which was 14, looking at this one, which was 7, well, the interquartile range is the distance between those two, which you can see from that lovely little purple arrow, is 14 take away 7, which is, of course, is 7. So that would be called the interquartile range. I'll say it one more time because it's not on the diagram, an interquartile range. Okay? And that's reading box plots, all right, essentially. The last part of this kind of lesson is really about comparing. All right, so we haven't really looked at that so far. We've just been looking at drawing them and plotting them, but not really kind of comparing them. So if you're given two box plots, you may be asked to identify how you can compare those. All right, so you should be able to compare the median because you know where that line is, and you might be able to compare which has a particular higher average. All right, you should also be able to compare the range of an interquartile range to see which set of data is more consistent. And I'll talk about that in a minute when we see an example. Okay. Right, so here's our example. So the box plot shows heights of plants with 2 different fertilizers. And so which fertilizer produces the best results? It's as simple as that, really. So this is not about kind of necessarily giving a specific, this is best and this is not the best. This is about deciding and giving reasons why it's the best. And you'll come across these questions already where it's the idea of saying, is A or B better? And hoping to say, well, if it's A, I would get a mark for it without any kind of justification. Well, that's not going to work. And similarly with this one, without any kind of justification, you can't say that the top one is best or the bottom one is best without kind of clear justification. All right, so we're going to compare. So when I'm looking at these two, fertilizer A is best because, all right, well, which is fertilizer A, first of all? Well, I'm assuming it's this top one. Okay, so let's say this top one is fertilizer A. And why is it best? Because if I look at the median for this one is 31, and the median for this one is 30. So it's got a higher median average, hasn't it? All right, a higher median average. All right, so that's one thing we can say. The median's 1 centimetre higher, which means the plants are taller on average based on the median. We can also say, but because this box is smaller, then the values that we are getting are more consistently in this area. Where compared to the one at the bottom, B, then these are a little bit more spread out. Meaning median isn't quite as consistent and we don't know what results we'll get. And again, if I compare that to the range of information we get, well, again, we might get some good results, but on average, we get a big spread of information, whereas here, that's where most of our data comes. Yeah, we've had a couple of blips, and that might be due to some random rain. It might be the fact that some animal has eaten it. I don't know. But it's most of the data is kind of in there. All right, so that's probably our second reason. So let's have a look. So the interquartile range of A is 5. That's this little gap. And the interquartile range of B is 7, which I've just kind of mentioned, bigger. So first letter A produces more consistent plants. All right, so it's quantifying what you're actually saying. So it's looking at the information. They're not just saying A is better or B is better. It's saying A is better because. All right, it's that justification is what they will be looking for in the exam. Hopefully that makes sense. So just to kind of clarify, we're looking at compare the medians, see which is bigger, compare the size of the boxes to see which is more consistent, and obviously make a judgment based on that. And again, that's what they'll be looking for in exam. All right. If you need any more practice or any kind of content, as I've said in most of my videos, please visit mathschool.co.uk. There's lots of kind of content, all my other videos on there, and there's a bunch of also practice questions for you to have a go at. All right. Any problems? All right. Please just get in touch. If you obviously like this video, please click the share and like below. Thanks very much.